That's good.
Okay, so if we follow the tip of making it look like the other form, on the first one, the easiest thing to do is going to be to factor the top, because right now it's foiled.
I just pump it in.
That's what I
Yes, that will also work. So if you factor the top, if I make two sets of parentheses, and I fill in x and x to make x squared, then I'm looking for two numbers that multiply to give me 6 and add to give me 5. So 2 and 3. 2 times 3 is 6 and 2 plus 3 is 5. I can also use the bottom as a hint, because if I'm supposed to factor, there's got to be a purpose to it, which would hopefully be to cancel. So if I know that x plus 2 is one of the factors on the top, then x plus 3 has to be the other one, because 2 times 3 is 6. So that lets me cancel out the x plus 2's, and I get x plus 3 is 12, so x would be 9.
Yeah, I just pump it in.
Did you plug them in? That works too. In fact, you can type into y equals on your calculator. You could type in this equation. I mean, you could type in this expression, so I could type in, oh good Lord, plus 5x plus 6 divided by x plus 2. And then I could go to the table and look at these values and see which one gives me 12. So negative 2 doesn't work, 2 gives me 5, 3 gives me 6, 6 gives me 9, 9 gives me 12. So I can also use the calculator to help me figure it out. Or you can just plug in answer choices. Right. Okay, again, on the next one, if you recognize that this can be factored because it's a difference of 2 squares, and you factor it, a squared minus b squared would be a plus b times a minus b. Well, I know that a minus b is 3, right? So what does a plus b have to be in order for these to multiply to give me 21?
19. No, 8.
7.
A has to be 7, right? 7 times 3 would be 21. A plus b has to be 7. So, if I know that a plus b is 7 and a minus b is 3, then what would a have to be? A would have to be 5. Right? So that 5 plus 2 would give me 7, 5 minus 2 would give me 3, and 7 times 3 would give me 21. Did you get that one?
Yes.
You did.
Plugged it in
Did you plug in?
now.
Yes.
So you plugged in and got, if A was 5, then B would have to be 2, and so then you said 5 squared minus 2 squared is 21. Yeah, that works too. Okay. All right. If x is less than 0 and we have this, then x squared is what? Okay. Well, right away I know that it's not a or b, because x squared, when you square something, it's always positive. So if I'm looking for x squared, squaring something, it shouldn't be negative. So it's got to be c, d, or e. It's probably also not going to be c, because if this is x squared, then that would make x the square root of 3, which when I plug it in here isn't probably going to give me a nice number like 25. So I'll probably, if I was going to plug in like y'all did on the other ones, if this is x squared, then that would mean x would have to be negative 2. And this means x would have to be negative 3, because remember, x has to be negative. So you can plug in. Now what I would do though is, since this is not foiled, I would foil it. Which if I did, I would get this. No, I lied. I wouldn't do that. I would not do that. I would try to get x by itself. So I would take the square root of both sides. So I would have this. 2x minus 1 equals plus or minus 5. Because the square root of 25 is 5. And then I could solve for x. So I would get that x is either 1 plus 5 over 2 or 1 minus 5 over 2, which would give me 3 or negative 2. And since x has to be negative, it would be negative 2, so x squared would be 4. That one was hard. There's really no easy way to work it, because even working it out with algebra wasn't easy either. So probably plugging in would be just as easy on that one. You just have to recognize what to plug in, that these are all x squared values. But what you would have to plug in would be x. So you'd have to go through and figure out from each of these what x would have to be, but you would know what to plug in. Okay. So the next one. This is one of my favorite things on the SAT because it's something that you did learn in your math classes, but when you learned it, oh, y'all don't want to see a pattern from my skirt. It's one of the things that you learned in Algebra 1 and again in Algebra 2, but when you learned it, it was a lot harder than it is on the SAT, which is one of the few things that that's actually true for. So what this is, they call them simultaneous equations. When you learned them in your classes, they were called systems. And it just means that you have two equations with two variables. And on the SAT, when you learned them in math, there were like 3 or 4 different ways you could solve them. Well, on the SAT, there's one way that works every time and it's easy. You just stack up the two equations and either add them or subtract them. If you choose the wrong operation, it's no big deal because you just have to go back and do the other one. So for example, if I have 2x plus 3y is 12 and 3x minus 3y is negative 2, what's the value of x? I'm looking for a variable in a two-variable system or a set of simultaneous equations. So you just stack them up, and then I'm going to add straight down. 2x plus 3x is 5x. The y's cancel out. 12 plus negative 2 is 10. Divide both sides by 5. X is 2. Okay? And on the SAT, they'll always work with either adding or subtracting. If I had done this and the y's hadn't canceled out, then I would go back and try subtracting to try to make them cancel out. But they'll always work out really nice like that. Okay, so let's try quick quiz number 3. And you'll notice these are all medium, because that's really where you're going to find these on the SAT, is in the medium. So take a minute to try those.